Hello, everyone. Good afternoon, and welcome to this special webinar on Southern Plains drought conditions. My name is Eleanor Hassenbeck. I am a communications specialist at the National Integrated Drought Information System, also known as NIDIS. If you're not familiar with NIDIS, you can learn more about us at drought.gov, and there you can also sign up for email alerts that will notify you when drought statuses change in your zip code. And just a note, I also sit at the Cooperative Institute for Research in Environmental Sciences at the University of Colorado in Boulder. First, let me cover some housekeeping items. On this webinar, everyone is muted and the webinar is being recorded. The webinar recording will be available on the NIDIS YouTube channel and linked from the webinars page at drought.gov/webinars. We will send an email when the webinar recording has been posted. If you're not receiving Southern Plains drought emails, you can sign up at www.drought.gov/drought-alerts/signup. The URL is also there on the slide, and there's the QR code as well if you'd like to sign up on your phone. Go ahead and select Southern Plains Drought Early Warning System from the regional mailing list menu there to sign up. We will have time after both presentations for a question or two. To ask a question, please use the question box, which is located within the GoToWebinar control panel. I'm really looking forward to our presentations today. First up, we're going to have Joel Lisenby, who's the Regional Drought Early Warning System Coordinator for the Southern Plains region at NIDIS, where it's his goal to reduce the costs and impacts of future droughts in Kansas, Oklahoma, and Texas. Following Joel's talk, we will hear from Sharon Mesick about NOAA's Atlas 15 project. Sharon is the Regional Climate Services Director for NOAA's Southern Region, which is part of NOAA's National Centers for Environmental Information. Sharon will be retiring from NOAA at the end of this month, and she's been a huge asset to the Southern region, and we wish her the best in her next adventures. And then I'm going to hand it off to Joel.
Thank you so much, Eleanor. So I'm really excited to be able to talk to you today about the present and possible future drought conditions across the Southern Plains. First of all, just a little bit about NIDIS. I'm pretty sure that probably 90% of you on this webinar right now are familiar with us, but for those few that aren't, I just want to let you know about what we do and who we are. NIDIS it's an acronym, of course, for the National Integrated Drought Information System. It's a multi-agency partnership with a mission to mitigate the impacts and the costs of drought by improving the nation's capacity to proactively manage drought-related risks. We do this by pulling a few different levers. One of the levers we pull is by focusing on regional needs across the nation. So we are divided up into regional drought early warning systems, for which I coordinate the Southern Plains system. We also work on supporting drought planning and preparedness. We support drought impact assessments. We strengthen collaboration. We improve drought prediction and forecasting. And also, if you ever go to drought.gov, that's us. We provide that tool for everyone to use to get the information they need. Okay, so that's enough about who we are. Let's talk about the drought for a minute. Let's start by looking back at the past 5 years of drought across the Southern Plains region. The Southern Plains has been in drought for almost 5 years now, but it hasn't been a single drought. It's more been multiple droughts that have moved around the region and changed in intensity from time to time. If you look back in early 2020, there was a drought down in the lower Rio Grande Valley. And just as that drought was improving around June, July 2020, we started seeing drought intensify over eastern New Mexico and western Texas. This drought spread and intensified further through almost the whole next year. From about June 2020 through June 2021, we saw periods of exceptional drought across the western part of the Southern Plains. Around August and September, there was nice summer rains. We had a really good monsoon that year. The drought ameliorated. It didn't go away completely, but we thought, hey, the drought is over. And Mother Nature was like, just kidding. And by October, drought started developing again across the western part of the Southern Plains, and it spread across the northern part of the plains, which includes Texas, the northern part of Texas, the Texas Panhandle, Oklahoma, and Kansas. And this drought again intensified and spread until most of 2022 was in this drought condition. Some areas were better than others, but we had pockets of exceptional drought, or D4 drought, based on the U.S. Drought Monitor categories that covered most of the region. This started improving a little bit in the summer 2023, but then it intensified again with a flash drought that developed over eastern Oklahoma and eastern Texas in September 2023. You might remember this was when parts of Louisiana caught on fire. It was pretty bad for the eastern part of Texas. Things have gotten a little bit better, but we still have pockets of drought. Through 2024, we had pockets of exceptional and extreme drought across parts of the region, especially in the West. Let's look at just what's been going on in 2025 so far. Right now, I'm showing the precipitation percentiles for the region, beginning from January 1st through the end of March. So this is a 3-month precipitation totals compared with all historical totals for that same time period. And we can see across the region, we've got some areas that had their driest start to the year on record. This is parts of western Texas, the Texas Panhandle, even eastern New Mexico. And we even have a few pockets in southwestern Kansas that have seen the driest start to the year on record. This map also shows an area that had the wettest start to the year on record. Or was it? I want to deep dive into what happened in the lower Rio Grande Valley for just a little bit. Here I have outlined the southwestern Texas coastal catchment, and I'm averaging all of the precipitation over just the area within that outline. And I'm showing the daily progression of precipitation for this lower Rio Grande, the southwest Texas coastal catchment. And as it turns out, this was a very dry start to the year. It wasn't a record, but it was certainly within the bottom 10% of historical precipitation totals up until toward the end of March. In fact, February, I was sure February was going to rank the driest February on record for this, but there were a few Februarys that had actually zero rainfall for that month. So this year, our February total, I think it was 1/10 of an inch, or maybe even less than that, but it didn't set a new record. But then something happened on March 26th and 27th. We had this massive rainfall event that took the region from one of the lowest bottom ranked 10 years on record to one of the wettest years on record. I need to go forward. This is a graph that I'm pulling from the National Weather Service, the Brownsville office, is a graph they made following that 2-day precipitation event. And this is data that was put together using surface observations and radar observations, and then corrected for the bias to give us an estimated total precipitation across this whole southern Texas region. Every place received at least 2 inches of rain over those 2 days, but you had a few pockets of really heavy rainfall. The areas in blue had over 8 inches of rain. The areas of purple had over 14 inches of rain in those over that 2-day period. I want to break this down a little bit more. Like, what does this mean? How extreme was this event? Right now, I'm just to the left, I'm showing Atlas 14 precipitation data. This is NOAA data that diagrams the intensity, duration, and frequency of these precipitation events. I'm pulling data here from the Harlingen Valley International Airport site, and I'm going to walk through how to interpret this graph, how we should understand it, and what happened. So first, starting on the y-axis, we're going to find how much precipitation fell that we're looking at. And in this case, that purple range around Harlingen, it's between 16 and 18 inches. So I'm just drawing a line around 17 inches. And I follow that line over to the duration, which this amount of rain fell within 2 days. And that gives us a dot somewhere between this light blue line and this cyan line. And when you come over to this little key, it works out to an average recurrence interval of somewhere between 200 and 500 years. So we fall in right there. So we colloquially will say that this was a 200 to a 500 year precipitation event. That's a bit of a misnomer. There's a more correct way to describe that, and that is that in any given year, there's a 0.05% chance of this to a 0.02% chance. So that's the range of this amount of rainfall falling. So it was a very extreme event. It was the amount of rain that you wouldn't expect to see more than once in your lifetime, although it could when you're talking probabilities. So it was enough to eliminate the drought that was analyzed across that southern part of Texas. So here I'm showing the U.S. Drought Monitor class change map for that 1 week period from March 25th through April 1st. So this extreme precipitation event happened within that window, within that week. And if you look down around that bit of southern Texas, we saw a 2-category improvement in drought from just that one precipitation event. In fact, it erased drought following that. Lots of rain, a big event. Let's now look at, outside of just that one precipitation event, how has drought progressed over the year so far? So this is beginning on the first week of January and continuing through to last week. And you can see that we've had some areas of drought intensifying around the Texas Hill Country, the Big Bend region of the Rio Grande. We also have seen drought develop, a moderate to severe drought, or D1 to D2 drought, develop over much of western Kansas and Oklahoma. I'm going to stop this animation just to show the most recent U.S. Drought Monitor map, which was released this morning. And it shows a broad area of exceptional drought extending from El Paso over to about San Antonio, with areas of moderate to severe drought across western Kansas and western Oklahoma and western Texas. So drought is still around, and it's going to probably be around for a little while longer. Let's look at some other indicators of drought, more so than just the U.S. Drought Monitor. This is looking at the 28-day average stream flow. This is USGS stream gauges, and you can see that on the average stream flow for the past 28 days shows continued hydrologic drought across central Kansas and central Texas. These are areas that have been in drought for several years now, and the hydrologic drought is continuing to show that. The temperatures over the past week, and this is April 14th through 20th, there was a bit of a lag in the data, and I also made this presentation yesterday, so this is a little bit lagged, but the temperatures have been higher than average for this time of year for most of the region, with a few areas in near the Oklahoma Panhandle, so like western Oklahoma, that have seen 6 to 8 degrees above average for this week. Evaporative demand for the past week, this is even an older week because of the data lag here, but the evaporative demand has also been higher than average for this time of year for most of the region, which is one of the things we look at when we're considering if drought is getting worse or not. Are we seeing a lot of evaporation happening? Is water being pulled from the landscape, especially is it being pulled faster than precipitation can replenish it? I'm now showing soil moisture. This is the upper layer soil moisture, so that top meter of soil. This is modeled soil moisture from the NASA SPORT model, and it shows lingering dryness across Kansas and also along the Texas I-35 corridor from about Dallas down to Austin or so. So we still see pockets of drought or drought indicators that are suggesting that this drought that's been around for a while is still here, and we're still seeing some of that impact. Let's look ahead now at what changes might be happening to our drought conditions across the region. I'm going to start by talking about the El Nino Southern Oscillation. We usually look at ENSO, summarizing it as ENSO. We look at this to give us longer term predictions. It has a stronger correlation with precipitation during our winter months, and less so during summer. So this will give us somewhat of an indication of what changes might be coming, but it's something we usually look for coming into fall rather than going into summer. On the top right, I'm showing the Nino 3.4 index. You can see the boxes over the map. The 3.4 index is something that with a name like that could have only been named by a scientist, but it overlaps the Nino 3 and the Nino 4 regions. And we usually use this as the general indicator of how strong the driving or the forcing from the ocean is on our weather patterns. Looking back to early 2021, we had this La Nina event. It went away, but then it came back again. In 21 and 22, we had fairly weak La Nina patterns. Last winter, like the winter before this last one, so the 23 to 24 winter, we had an El Nino event, which you can see from the time series where the line goes above the pink dashed line. And then the ocean, the central part of the ocean, Pacific Ocean, cooled off again, and we had a weak La Nina event. This is using just straight observed Nino 3.4 index values. I'm going to overlay a relative Nino 3.4 index, and this is an index that has had the warming trend in the oceans removed to give us a little bit more of a comparison with past events. And that's this blue line. And you can see when we're using the relative Nino 3.4 index, both this last El Nino event and the weak La Nina that we saw over this last winter, 24-25 winter, were the line shifts down just a little bit for both of those events. And it's very possible that the impacts from this La Nina on our weather patterns over the last winter were more exaggerated than what just the direct observed Nino 3.4 index would have shown. The graph on the bottom right shows the exact same index, but now forecast forward for the next, toward the end of this year and early 2026, based on a myriad of different seasonal climate models. And the quick key takeaway from this is that there's a lot of uncertainty. The models spread out. They're not all agreeing with each other, but when you take the average of all of them, which is the thicker red and green lines, ENSO is forecast to stay neutral through the rest of this year. We can look at this in a bar graph to sort of visualize it a little bit better. So this is essentially counting up all of these different models that I'm showing on the bottom right and showing how many of those models fall within an El Nino pattern, how many fall within a La Nina pattern, and how many fall within a neutral pattern. And you can see that the most likely outcome is a neutral ENSO pattern through the end of this year, with slightly increasing odds of La Nina and El Nino, both, but neither as likely as a La Nina. So that's sort of big picture. If we were to bring it in a little bit to look at just what's going to happen over the next week, here I'm showing a map where the shading is the predicted precipitation for the next 7 days from yesterday. And the contour lines are last week's US drought monitor categories. We can see that there's a lot of rain expected for parts of the Southern Plains region, especially eastern Kansas and eastern Oklahoma. Unfortunately, it looks like, based on this last forecast, most of this rain is going to miss the most drought-affected areas. Looking a little bit farther ahead of this next week, this is the 8 to 14 day outlook with precipitation on the left and temperature. It's the map on the right, but it's in the middle of the slide. Also with the contours showing last week's US drought monitor categories. The odds are in favor of a cool and wet week ahead. This is the first week of May, although where the odds are strongest for above normal precipitation, it just barely misses the parts of Texas that are seeing the most extreme drought. But there's still a chance that we could see above normal precipitation for western and central Texas. This is looking at the same things, but it's taking the next step forward. This is step forward in time. This is looking at the whole month of May, where overall May is likely to be warm with equal chances of above or below normal precipitation. And this is looking ahead at May through July. So this 3-month season, May through July, is likely to be warm. There's a slight chance for below normal precipitation through that 3-month period. Taking all of this information together, the Climate Prediction Center produces a drought outlook. This is looking at the 3 months from April through July. And overall, while we might see some short-term improvement in drought conditions over the coming weeks, overall drought's likely to persist through July. And I'll finish up there, and I'm going to pass over now to Sharon to talk to us about the Atlas 15 project.
Thanks a lot, Joel. I'm going to share my screen here. Y'all let me know when you can see this and be sure you can hear me.
We can see it and we can hear you.
Okay, great. So thanks for giving me an opportunity to speak to the group today about the progress of Atlas 14. We're going to tell you who we are, what we do, and give you opportunities to give us feedback on this exciting development. So let's see if my slides will change. There you go. So y'all know that Atlas 14, which Joel was pulling on that data for some of his slides, it's going to show you the historical rainfall data and forecast and predict rainfall intensity and flood risk by volume. And all of these volumes were not created at the same time. The volumes that cover this particular DEWS region are from 2013 and 2018. And so that makes it really difficult to apply to what's happening today when you're designing and operating infrastructure like stormwater ponds and runoff and so forth. So during the Biden administration, NOAA Office of Water Prediction was given some funding to update to Atlas 15, and a big focus of this is getting feedback from users during the course of development, as opposed to delivering a product at the end of the day that may or may not meet your needs. We'd really like to hear from you as we go through this process. And there are a couple of other opportunities for providing us feedback that we'll identify for you. This is the proposed timeline. And you can see here in the solid red line box, we've been collecting feedback on this since 2024. So there was an opportunity to provide feedback on the technical documentation, which described the methodology for developing the data for Atlas 15. And then where we are now is collecting feedback on the web dissemination portal. This is being done as a pilot project initially for the state of Montana, but the user interface is what we're really looking for feedback on. And when the data for CONUS, which would include your states and region of interest, when that's available, which we estimate to be September 2025, there'll be another window of opportunity to give feedback on the data itself as well. So a couple of opportunities, one now and one in the future towards the end of the fiscal year. So this is our group. We work with the NOAA Office of Water Prediction, who is doing the development. I'm with the National Centers for Environmental Information, and my colleagues who will be talking later in the presentation, Joelle Godwin and Alexandria Smith, are with this Riverside-led contract that's focusing on user engagement in our region. And while we're really talking primarily to the transportation and water resource sectors, we're not so innocent to believe for a minute that everybody isn't affected by this, and you all use transportation and rely on water resources. So we really want to hear from you and see how beneficial this product may be for you, or what you might like to see in it that you don't see now. So just a quick comparison between Atlas 14 and Atlas 15. I would say that the biggest difference here is the date, right? So Atlas 15 is being updated from all those various volumes into one volume for CONUS, and it's being updated with the 2023 data. And then it also, in Atlas 15, gives you the option for planning scenarios out. And so we'll talk about stationarity and non-stationarity of the data. Atlas 14 did not assume that there would be any change over time, and Atlas 15 gives you the option to take a look at potential change over time in scenarios that you define for yourself that provide options in the map interface. So to describe that a little further, Volume 1 will show you the estimates for 2023 based on historical observations, so very similar to the way that 14 was described. Volume 2 is going to take those estimates, downscale the model data, and look at future time period frameworks. And so it gives you, as I was describing, the opportunity to look at a global temperature index and to look at different emission scenarios. So this is an overview of what the website will look like. And the reason I have it set up like this is because I want to describe how the two volumes are interrelated in these maps. And so you can pick your location, you can pick your background, if you want to look at a satellite imagery, you can define your opacity, you can look at the stations where the data are collected. And you'll get a map that gives you that result. And then in Volume 2, where you plan your scenarios either on the global temperature index or in emission scenarios, this will update. And as you're updating these, your charts will update, the tabular data behind the chart will update, and then you have an opportunity here to look at the precipitation frequency estimates, and you have choices to make here as well. And so one of the key things that we're looking for feedback on is how easy is this user interface to use, and if you were going to use the data here, how would you like it delivered to you? Would you integrate the data into a model that you yourself run? Would you like to be able to look at this more closely than the state level, say in terms of a watershed or other regional delineation? Do you want geospatial files? I mean, it's that level of detail that we're looking for to get feedback from users who who use Atlas 14 now and are looking forward to using Atlas 15 in the future. So just really quickly, because this is really hard to see, and I don't really have time to do a demo, but you can run this for yourself. Um, this is a close-up on the map, and you can see here that in volume 1, I picked Billings. So I did say that the pilot is only for the state of Montana. So I went for the city that is the largest in Montana, which is Billings. I used the regular topographic background. I set the opacity sort of randomly. I set the time series. And then over in volume 2, I elected to look at the scenario with emissions at 2.45, and then I set it out to 2080. So let's assume that I'm planning something that I expect to last for 50 years. And I looked at the annual exceedance probability over a 3-hour time frame. Now, again, all of these are adjustable for you. And then what you subsequently see from these selections that I made is a chart. This is interesting because in the legend, you can select to turn on and off these different color-coded chart components. In the table, you can see I selected what data that I might want to have access to. And then in the precipitation frequency estimates, I did the same. And you'll notice here too that you can add an additional projection. So I picked a more extreme scenario. I picked the same time frame, and you would see this update, and you would also see an update here as well. So now I'm going to turn it over to my colleague Joelle Godwin, who's the strategic coordinator with the Atlas 15 user engagement contract. And she's going to tell you a little bit about how you can provide feedback into the system so that we can hear from you about what might be useful. So Joelle, can you unmute yourself?
Yes, thank you so much, Sharon. I appreciate it. And I'll try to be brief. I know we were packing a lot of information into a short amount of time, but that overview of Atlas gives you a taste of what Alex and I, who are continuing on to do user engagement, can do. So if anybody's interested, we would love to have you reach out to us. We can tailor a user engagement presentation for you and talk more about the full product release, show a demo of what it can do, and gather your feedback, because we're very interested in any gaps that you see, any kinds of data formatting that would be helpful to you. How does this climate tool of Atlas 15 affect your decision making and support what's happening in your organization or in your stakeholder support? So we are really interested in what guidance that we can gather from you, that we can translate and give back to the developers as we approach the full rollout in the fall of 2025. And it's exciting because instead of just doing volume by volume, the entire continental United States Atlas 15 data will be released at the same time. So with that, I would say please reach out to us. My name again is Joelle Godwin, and yep, there's the summary of the Atlas 15 information links. This will be sent out later so you can take a look. You can play around on the pilot website and get very up close and personal with the capabilities of what Atlas can do on that pilot website. And we'd love to talk with you. So if anyone has any questions, we're happy to answer them.
Thanks, Joelle. I'll just close out by pointing out that even though I buzzed through these screen snaps really quickly, one of the links here is to a quick start video on YouTube about how to run this portal, and it actually is really pretty good. It's very short, and will show you a lot of the things that I pointed to that you can then try out for yourself and see how it works for you. So with that, I'll stop sharing, Joel. I think. There you go.
Excellent. So we're going to turn into Q&A, and I actually have a quick question for you, Sharon. Would you be able to drop some of the links in the chat of those resources that you just shared in the slide? That would be super helpful.
Sure, we can do that, and then we can also send you the presentation so you can distribute it to your listeners if you would like to do that.
Okay, excellent. So again, we're going to take questions, so please go ahead and use the question box. It should be part of it's most likely in the top right corner of your screen if you want to ask anything of Joel or Sharon or Joelle. But just to start us off with Joel, with the recent dryness, or I guess continued dryness, what are you seeing in terms of fire risk for the summer? And are there any other drought impacts that you think that we should be watching out for as we enter the warmer months?
So that's a great question. Thanks, Eleanor. Um, so the National Interagency Fire Center produced seasonal fire risk outlooks for months ahead at a time going forward, and these incorporate current and expected drought conditions as well as fuel load on the ground. And their prediction coming into spring was an increased risk of wildland fire potential for most of the western part of the Great Plains for the month of April. That eases off a bit in May and in June, but by late June and by July, well, by June they increase the wildland fire risk again through the central part of the region, and then that region expands, or the area of increased wildland fire risk expands to include most of the eastern part of Texas and Oklahoma, going through the later part of the summer, so specifically for July. Anytime you see a period of a lot of rain where everything can grow, followed by a drought period where all of that growth can dry out, you see an increased risk of wildland fire.
Great, thank you. And again, please feel free to put any of your questions in the question box. For the Atlas 15 team, just to emphasize it again, what's the best way to contact you, either with user feedback or if you'd want to be more engaged in some of the user experience kind of testing that you all are doing?
Joelle, you want to take that while I paste
Sure.
here?
Absolutely. The best way to get in touch with me is to touch with our team is to email me. And I can send the organizers. I'm not able to post directly in the chat, evidently, but I can send you that, and we will follow up also with our slides, which has that as well. Sharon's been graciously posting all of the information around Atlas 15, so you can see those in the chat as well. Thanks, Eleanor, for sharing my email. That's terrific. I appreciate it.
Yes. And so we have a question. Is the radar input to this from MRMS?
Atlas 15? No, not to my knowledge. I would suggest that if you have that level of technical question, let me post the link to the technical report here, because I will confess to not really knowing for sure. So let me
Excellent. And
put
I
that
think
in here.
I'm going to connect, either I or Joel will connect you to this asker because I think that you all would both benefit from that connection.
Sure.
Another one related to impacts. Do the current conditions lead to poor air quality events like the dust event that the region experienced in March?
I'll take that one on. It's a great question. We think so. There had been some research correlating drought conditions with dust events over western Texas that found a fairly weak correlation, but we still think that when there's less vegetation on the ground, there, I mean, it's obvious there'd be more opportunity for dust to get picked up. It's possible that the dust events in western Texas are just part of the natural climatology of that region anyway. And when there are things that disturb the soil, like people tilling or plowing their fields, the climate is usually just dry enough to create these dust events. Certainly, there's this huge dust event last month that picked up dust in southern New Mexico and drove it across most of Texas and Oklahoma and farther east. The dust that got picked up in that event was in a region that was experiencing exceptional drought at the time, and uh, it's it's logical to expect that when you have the dry conditions, you can see more dust. But this research is ongoing, and we'd love to understand this area of drought to air quality better than we do.
Great. Thank you, Joel. And we are up against the end of our allotted time. So we are going to wrap this up. I'm going to give Joel and the Atlas 15 team like 10 seconds, 15 seconds if you want to add anything else.
I just want to say thank you for being good listeners, and I hope that y'all will reach out to us with any further questions or opportunities to talk to your group or interested folks that you may know. So thanks a lot.
And I'll just say a quick thank you to you, Sharon. I know that you're coming up close to retirement. Thanks for giving us a bit of your time to talk on this webinar, and I wish you the best in retirement.
Thanks so much. I really appreciate it. You've been great to work with, Joel.
Alrighty, you all. Thank you so much for tuning in, and thank you to Joel, Sharon, and Joelle for presenting for us. And we hope you have a great Thursday afternoon.